Welcome back to Series 3 of the Atari ST Nostalgia GFA Basic Tour. In the last video we created some cool full screen smooth scrolling animations by pre-shifting screens. But in this video we go back to our sprite animation to explore another way of doing this by using GFA's built-in BITBLT functionality. And when reading the manual, BITBLT actually looks kind of intimidating with all these parameters you have to set. And then the example code unfortunately has no educational value whatsoever when it comes to learning the command. But once you get the hang of it, it's actually quite workable. So this will be a 3-part mini-series where I will take it very much one baby step at a time. And in this first part we will just get to know the BITBLT command and practice a little bit. So I am going to my editor and I've created some example code to sort of practice with the command. And what I'm going to do is I'm going to do the same thing 3 times, which is to draw 2 boxes, like one with Atari logos and below that a completely black one. And I am going to use 3 different methods to grab a section from the top box and put it down in the bottom box. And the first thing I'm going to do is with the rccopy command that we already know. So basically I'm going to use rccopy from my current write screen and get the coordinate 16 by 16 with an object width of 160 pixels and an object height of 96 pixels. And I'm going to copy it over into the same screen, but at coordinate 74, 254. And I'm going to use the put mode 3, so the replace mode, as we saw in part 32 and also in part 26 where we learned about all the put modes. And then I'm going to redraw the boxes and then I'm going to do one of the 2 variants of the BITBLT function or the BITBLT function. And I'm first going to use the VDI BITBLT function, which uses 3 arrays as its input. So I need to create an array with parameters of the source screen. Then I need to create an array with parameters of the destination screen. And I need an array with parameters of what and how we want to copy. And because it's these 3 arrays with all these parameters, it makes it look a little bit intimidating, but actually it's pretty easy. And in this case, for source and destination, we use the current screen. So in this case, my blit source field 0 will be the address of the source screen. In this case, it's x_3, so my current screen. It wants to know the width and height of my screen. So in this case, 640 by 400 because we are working in monochrome. And then it wants to know the width of the screen in words, which basically is the value of this one, blitzscreen 1, and divided by 16. And element 4 of this array is always 0 because it's reserved and probably will never be used for anything anymore, since it's now, it's a really old language. And in element number 5, we need to provide the number of bit planes. And we are working in monochrome, which means the number of bit planes is always 1. And in this array, elements 6 and 8 were reserved for future extensions, which by now we can assume that they will never be used. Which also means I can probably make the array a bit smaller, but to keep things clean, I will make this array the 9-element array as the manual sort of prescribes. And if element 0 of the source or destination screen array is actually set to 0, the BITBLT function will basically determine the values by itself. It will take care of it by determining the values by looking at the current screen. So that's what I did in this case. I just set the first element to 0 and I don't have to worry about any of the other parameters. And the copy parameters are actually also quite straightforward. In the first four elements, so 0 to 3, I have to provide the top left and right bottom x and y coordinates for the source. And then in the next 4 elements, so 4 up to 7, I have to do the same top left and right bottom coordinates, but for the destination screen. And in element number 8, I will have to write the copy mode, which in this case is replace mode, copy 3. And again here also the numbers are exactly the same like the put modes we used in part 26 and part 32 for the put command and the rccopy command. And of course after all these values have been set, which you do before, then applying the command is actually really simple. You just say BITBLT, please execute, use this array for your source screen parameters, use this array for your destination screen parameters, and then use this array for your copy parameters. And that's basically all there's to it. So it's a lot simpler than it really looks in the beginning. And of course for BITBLT there are 2 variants. This is the VDI variant, which is the most compatible and probably the easiest to use of all of them. But there's also a Line-A call variant, which I'm also going to show, and I will also test it later. And in this case, instead of 3 arrays, it uses only 1 array. So basically you say execute please and use this single array for all your elements, which makes the command look a little bit intimidating because you have to set all the source and destination data and all the copy parameters in 1 array. But even in this case, it's actually pretty straightforward. All you have to do is provide your width and your height in pixels for the object that you want to copy. Then you provide the number of bit planes again, which in monochrome is still equal to 1. Then it wants to know a foreground color and a background color. For in this case it's 1 and 0 because I only have black and white in monochrome. And then it wants to know the put mode, and in this case it wants to know the put mode by using this hexadecimal value, and I don't know why they implemented it like this, but here I'm going to use put mode 3, which corresponds to hexadecimal value 3030303, and basically I can vary replace the 3's in here with either anything between 0 and F, because F in hexadecimal is 15 in decimal values. So in that way I can put all any put mode I want. So for instance, if I want to put it transparent, it would be 70070707. And then it wants to know the source coordinates. So the X and the Y coordinate, which in this case was still 16 by 16. And it wants to know the address of the source screen. And because I'm working in my current logical screen, I'm just going to provide XBIOS 3. And then it wants to know the offset to the next word of the same bit plane, which in monochrome is 2. And it wants to know the offset to the next line of the source screen, which in monochrome is 80 bytes, so I put 80 there. And it wants to know the offset to the next bit plane, which on a standard default ST is always 2, whether you are in color or monochrome or whatever. And then I have to provide these values, this set of values, but now for the destination screen. So destination coordinates, address, the same offset values as above, and then, yeah, that's it. There's 4 more values left, which is a pointer to a fill pattern that I can AND my object with before I put it in the destination screen. I personally don't really know how these 4 values work, so I keep them at 0, and I won't be going into them for the purpose of this video. And then from element 22 onwards, the BITBLT command, the blitter needs a workspace of 24 bytes. So I created a big array, so nothing else will be in that place when it wants to write it. In the manual they actually use dimension this with this number to set to 1000. I do 100, which should be big enough. It can probably be a little bit smaller, and I don't know if I really have to reserve the extra space. So if anyone knows, I'll be happy to take some advice in the comments, but yeah, if you use an array of 100 bytes, or sorry, 100 word values, it's not that big anyway. It's just like 200 bytes, so it's less than 1 kilobyte. So don't worry too much about it. And of course in this case also, after all values have been set correctly, I'm again doing the BITBLT command, but now provide the single array as input, and if it gets a single array with the correct dimensions, it will automatically use the Line-A call instead of the VDI call. And then after that I'm going to wait for a key and go to editor. So sorry, that was a lot of explanation all at once. But if I run the program, you see that this is the RC copy, which goes nice and smooth. This is the exact same result, but now with the BITBLT VDI command. And this is the exact same result, but now with the BITBLT Line-A call. So they all 3 of them work. And even if they look really intimidating, the good thing about all these values in the arrays is there's actually quite a lot of values that remain constant. So that you don't have to change. You set them once and then you don't have to worry about them anymore. And with that knowledge and the knowledge we just gained, I want to practice a little bit to see if instead of just doing this one copy, see if we can move an object around on the screen to prepare ourselves to apply it to a sprite animation, which we will do in the next part of this 3-part mini-series. So what I did here is I wrote some more code where I dimensioned the 3 same arrays again, and then the fixed values that BITBLT knows, I set them here because I only need to set them once, which means my source screen in this case will always be my sprite buffer. So these 5 values I never change. And for the destination, the dimensions of the destination screen are always the same. So 640 by 440. And I set the values here. And because I use screen swapping, I have to set the source address for my destination screen every time. And I can do it in 2 ways. I can just make element 0 of my destination 0 and let BITBLT determine all the values. But actually making these values constant and setting just the first element to the correct address within my loop is slightly faster. I tested it. It's not a lot, but if you have a lot of stuff going on, it's always better to have a little bit more performance, because now I have to set the address, which is one extra read-write inside my loop, but it doesn't need to determine these 5 values within my loop. It just can use them because they're already an array. I will show you in the loop what I mean. And then of course also for the copy, the source coordinates and the mode that I want to do. In this case they're always the same. So I set these values constant, and then I go into my loop. My BITBLT loop is basically I set my destination here. So I set it to my buffer screen. And it's faster to use this variable. I can also put x BIOS 3 here, but I saw that I measured and it's actually a little bit slower. Because probably if you put this, it has to execute the command to get the number, which is probably a little bit slower than just reading the value from this array, from this variable. The number from the variable, sorry. And yeah, then I do a cleanup. In this case, I'm still using the bmove cleanup like I did in part 32. So I determine the coordinate, the y coordinate, and then do a bmove of those scan lines. Yeah, then I make sure the angle is increased, and if it's bigger than 359, I set it back to 0. And then I actually put the object on screen, which means I have to write these 4 variables, these 4 elements of the array to do my destination coordinates, which is basically I use the synq and cosq commands to make it a nice moving pattern. And then 6 and 7 are actually like 4 and 5. I just have to add pixels for it to get the right dimensions. And after that, I'm going to blit and swap screens. And if I run the program, we can see, yeah, it's working. It's happily moving my pixel my object around, and it's only one object, so you can see it's pretty fast. So that's pretty cool, which means we can go to our next step, which is moving multiple objects. And in this case, I'm just going to move multiple copies of the same object, which means the procedure will get a little bit more complicated, but not by a lot. And in this case, the preparations, yeah, my arrays, and I still use the 3 arrays. And the fixed values are actually quite the same, so the source screen is always is not constant, and I will show you why. So the element 0 for blit source I have to set within my loop, and I will show within the loop why that is. And also the destination, these values are also constant. So this is almost the same except for the element 0 of this blit source screen. And of course my destination coordinates, the copy parameters are also no longer constant, because if I go into my procedure, the first thing I do is I set my destination again to the buffer screen like I did before. But now, just as an exercise, I decided to do the cleanup with the BITBLT command instead of bmove, which is probably slower. But I just wanted to exercise it. But this means for this array, I have to set the source address to my graph buffer first, because that's where I'm copying my cleanup data from. And then of course I have to set the copy mode to 3 because I want to overwrite the old sprite with the info of my background. Yeah, then I'm going to do the cleanup for 3 objects, which are 10 steps in the array apart. So in this case at positions 21, 11 and 1. And I have to set the source coordinates, of course, for each object that I want to copy over. So basically I use the xput and yput values from these element positions. And of course use the same method to have the lower right coordinates to determine them. And then of course I set the destination coordinates, which are exactly the same as the source coordinates, because I want to copy it over one by one. Then I do the BITBLT, so that is the cleanup. And then I'm going to insert the new coordinates like I did before. Then, because I want to move sprites, I have to set my source to the sprite buffer. And now I fix the source to my logo. So the source coordinates are the source coordinates of my logo within the sprite buffer. I have to set them within the loop. And it's all because I'm using only this one copy array. So that's probably not the best way to go about it. And of course the put mode I have to change again. And then I'm going to do from positions 20, 10 and 0 in the array. I'm actually going to determine the destination coordinates, because I have to set the source only once in the loop, but I have to do this for every putting of the object. And then use the BITBLT command again. And if I print it, we can see, yeah, this still works. What we also can see, it's gotten quite a bit slower. Because I'm now writing a lot of values and also maybe not using the command in the most efficient way. And that's something for the next video to work on. But now the most important thing is, yeah, we got to know the command, but as you can see, the way that I did it before, because I'm only using 3 arrays, so I'm using the same copy array all the time and the same source array, etc., which means just for these 3 objects, the 3 copies of the single object, I need 44 variable read writes within my loop. And that's probably not the most performant, because remember that for performance, what we need to do is actually reduce the amount of memory read writes as much as possible, and that includes reading and setting variables. We learned this in part 22b and also in part 32 when we were actually optimizing our sprite routine. But here BITBLT has sort of a problem, because we cannot hardcode values in our code like we did with RC-copy. We have to use variables from the arrays, and in this one, for just moving the 3 copies of the same object, I already need 44 read writes inside the loop, which is quite a lot. And And with 12 different sprites in our sprite routine, that's going to be a problem unless we really change our approach. And that is something that we are going to do in the next video. We are going to change our approach and we are going to optimize our sprite animation a little bit. So I hope to see you in the next part. For now, I would like to thank you for watching.